Download this code from codegive.com, link in the description below. OK, let's dive deep into Conductor workers. This tutorial will cover everything from the basic concepts to more advanced techniques, including code examples in Python, which is commonly used with Conductor. Table of Contents *. 1. Introduction to Conductor and workers. 2. Setting up a Conductor development environment. 3. Understanding Conductor workers. 4. Creating simple workers. 5. Worker configuration and registration. 6. Worker lifecycle and execution. 7. Error handling and retries. 8. Worker communication and data passing. 9. Advanced worker techniques. 10. Testing Conductor workers. 11. Best practices. 12. Troubleshooting. 1. Introduction to Conductor and workers. Netflix Conductor is a distributed orchestration engine that allows you to design, orchestrate, and monitor microservice-based workflows. It provides a visual workflow editor, a REST API, and a UI for managing and monitoring workflow executions. Key concepts workflow a series of tasks or steps that need to be executed in a specific order to achieve a desired outcome. Conductor workflows are defined as directed acyclic graphs, DAGs. Task a single unit of work in a workflow. Tasks can be implemented as microservices, scripts, or any executable code. Worker an application, or a part of an application, that listens for task requests from Conductor, executes the task, and returns the result to Conductor. Workers are the components that actually do the work defined in your workflows. Task definition a blueprint that describes a task, including its name, input parameters, output parameters, retry settings, timeouts, etc. Workflow definition a JSON, or YAML, document that defines the structure of a workflow, including the tasks to be executed, their dependencies, and the flow of execution. Why use Conductor? Orchestration centralized management of complex workflows. Decoupling decouplings microservices by orchestrating their execution instead of having services call each other directly. Observability provides a UI for monitoring workflow executions and identifying bottlenecks. Fault tolerance built-in support for retries, timeouts, and error handling. Scalability designed to handle a large number of concurrent workflow executions. 2. Setting up a Conductor development environment. To get started with Conductor, you'll need Java Conductor server is written in Java, so you'll need a Java development kit, JDK, installed. Version 11 or later is recommended. Docker, optional but recommended. Docker makes it easy to run Conductor and its dependencies, like Elasticsearch, in containers. Python, optional for running worker implementations. A Conductor client library for interacting with the Conductor API. Steps 1. Install Java download and install a JDK, example OpenJDK, Oracle JDK. Set the Java_home environment variable. 2. Install Docker, optional. Download and install Docker Desktop or Docker Engine. 3. Run Conductor server, using Docker. This command starts the Conductor server in a Docker container, exposing ports 8080, for the UI and API, and 5000, for gRPC. The eConductor_db_type equals memory flag configures Conductor to use an in-memory database, which is suitable for development. For production environments, you would use a persistent database like Cassandra or Elasticsearch. 4. Access the Conductor UI *, open your web browser and go to http://localhost 8080/. You should see the Conductor UI. 5. Install a Conductor client library * in your Python environment. This will install the official Conductor Python client library. 3. Understanding Conductor workers. A Conductor worker is a process that polls Conductor for tasks *. The worker periodically makes requests to the Conductor server to check if there are any tasks ready to be executed that match the worker's registered task definition. Executes tasks * when a task is assigned to the worker, it performs the logic defined in the task implementation. This could involve calling other microservices, performing calculations, manipulating data, or any other operation. Updates Conductor with task status *. The worker reports the status of the task back to Conductor, including the result of the execution, output parameters, error messages, etc. Key worker responsibilities *. Task polling * efficiently fetching tasks assigned to it. Task execution * reliably executing the task logic. Result reporting * accurately reporting the task status, completed, failed, in progress, and results to Conductor. Error handling * gracefully handling errors and retrying tasks if necessary. 4. Creating simple workers. Let's create a simple worker in Python that performs a basic addition operation. Explanation *. 1. Import libraries * import the necessary libraries from the Conductor client library. 2. Configure Conductor client * create a configuration object with the URL of your Conductor server. 3. Create a worker service * instantiate a worker service using the configuration. 4. Define the task logic *. The simple _addition function takes a task dictionary as input, which contains the task details and input data. It extracts the number 1 and number 2 from the task input data. It performs the addition operation and stores the result in the result variable. It creates a task result object, sets the output _data to the result, and sets the status to completed. If an error occurs, it sets the status to failed and provides a reason for incompletion. 5. Register the worker *. The worker _service.register method registers the worker with the Conductor server. You provide the task _name, the name of the task definition, and the function that implements the task logic. 6. Start the worker service *. The worker _service.start method starts the worker service, which begins polling Conductor for tasks. 7. Graceful shutdown *. The worker _service.stop method stops the worker service and releases resources. 5. Worker configuration and registration. The worker service class provides several options for configuring how workers poll for and execute tasks. Registration *. The worker _service.register, task _def_name, execute, method requires. Task _def_name, the name of the task definition that the worker should handle. This name must match the name defined in Conductor. Execute, a function, like simple _addition in our example, that implements the task logic. This function must accept a task dictionary and return a task result object. Worker configuration options *. You can customize the behavior of the worker service using the configuration object. Server _API _URL, the URL of the Conductor server API endpoint. Update _interval, the interval, in seconds, between polling requests to the Conductor server. Defaults to 0.5 seconds. Asterisk max underscore threads, the maximum number of threads that the worker service can use to execute tasks concurrently. Defaults to 10. Asterisk default underscore domain, the default domain for the tasks. Asterisk debug, enables debug logging. Example asterisk. Task definition, crucial. Before you run the worker, you must create a task definition in Conductor that matches the task underscore name used in your worker code, example simple underscore addition underscore task. You can do this through the Conductor UI or using the Conductor API. Here's an example of a task definition JSON. Explanation of task definition fields asterisk. Asterisk name, the unique name of the task definition. This must match the task underscore name in your worker code. Asterisk task type, the type of task. Simple is the most common type for worker-based tasks. Other types include HTTP, sub underscore workflow, etc. Asterisk owner email, the email address of the task owner. Asterisk description, a description of the task. Asterisk retry count, the number of times to retry the task if it fails. Asterisk timeout seconds, the maximum time, in seconds, allowed for the task to complete. Asterisk input keys, a list of the input parameters that the task expects. These parameters will be passed to the worker in the task input data. Asterisk output keys, a list of the output parameters that the task will return. Asterisk timeout policy, determines what happens when the task times out. Time underscore out underscore WF means the entire workflow will be timed out. Asterisk retry logic, specifies the retry strategy, example fixed, linear underscore backoff, exponential underscore backoff. Asterisk retry delay seconds, the delay, in seconds, before retrying the task. Creating a workflow definition asterisk. You'll also need a workflow definition in Conductor to use your task. Here's a simple example. Explanation of workflow definition fields asterisk. Asterisk name, the name of the workflow. Asterisk version, the version of the workflow. Asterisk owner email, the email address of the workflow owner. Asterisk description, a description of the workflow. Asterisk tasks, a list of the tasks in the workflow. Asterisk name, the name of the task definition to execute. Asterisk task reference name, a unique identifier for this task within the workflow. Used to reference the task's output in other tasks or the workflow's output. Asterisk type, the type of task. Must match the task type in the task definition. Asterisk input parameters, a mapping of input parameters to the task. $workflow.input.number1 refers to the number 1 input parameter of the workflow. $addition underscore task.output.result refers to the result output parameter of the task with the task reference name of addition underscore task. Asterisk input parameters, a list of the input parameters that the workflow expects. Asterisk output parameters, a mapping of output parameters from the workflow. Running the workflow asterisk. You can start a workflow instance using the Conductor API, example with curl or a Python client, or through the Conductor UI. You'll need to provide the name of the workflow and any input parameters it requires. Example, using curl. This will start a workflow instance of simple underscore addition underscore workflow with number 1 set to 10 and number 2 set to 20. The response will contain the workflow ID. 6. Worker lifecycle and execution. The lifecycle of a Conductor worker involves the following stages. 1. Initialization asterisk. The worker starts up, configures the Conductor client, and registers its tasks. 2. Polling *. The worker periodically polls the Conductor server for tasks that match its registered task definitions. 3. Task assignment * Conductor assigns a task to the worker if one is available. 4. Task execution * The worker executes the task logic defined in its execute function. 5. Result reporting * The worker reports the task status and results back to Conductor. 6. Loop * The worker returns to the polling stage and continues to listen for new tasks. 7. Shutdown * The worker receives a shutdown signal, gracefully stops polling, and releases resources. Task execution details *. Input data * The task dictionary passed to the execute function contains the input data for the task. This data is typically passed from the workflow or from other tasks in the workflow. You access input data using task input data parameter _name. Task context * The task dictionary also contains other useful information, such as task ID, the unique ID of the task instance. Workflow instance ID, the unique ID of the workflow instance. Workflow type, the name of the workflow definition. Task def name, the name of the task definition. Output data * The task result object that the execute function returns must contain the output data of the task. This data will be available to other tasks in the workflow and can also be returned as the workflow's output. You set the output data using task_result.output_data equals parameter _name, value. Status * The task result object must also indicate the status of the task. The possible status values are task result status. Completed, the task completed successfully. Task result status. Failed, the task failed. Task result status. In _progress, the task is still running. Use sparingly, typically for long-running tasks. Task result status. Cancelled, the task was cancelled. Task result status. Timed _out, the task timed out. 7. Error handling and retries. Error handling is a critical aspect of building robust Conductor workers. You should handle exceptions gracefully and report errors to Conductor so that it can manage retries and potentially fail the workflow. Error handling in worker code *. Use try, except blocks to catch exceptions that might occur during task execution. In the except block, set the task_result.status to task result status.failed. Set the task_result.reason_for_incompletion to a descriptive error message. This message will be visible in the Conductor UI. Example retries Conductor automatically handles task retries based on the retry count and retry logic defined in the task definition. If a task fails, Conductor will retry it according to the specified retry strategy. Retry count, the number of times to retry the task. Retry logic, the strategy for determining the delay between retries. Common retry logic options fixed, retries the task after a fixed delay. Linear_backoff, increases the delay linearly with each retry. Exponential_backoff, increases the delay exponentially with each retry. Setting retry logic in the task definition In this example, the task will be retried up to 3 times. The first retry will occur after 10 seconds, the second after 20 seconds, and the third after 30 seconds, linear backoff. 8. Worker communication and data passing. Conductor provides several mechanisms for workers to communicate and pass data to each other. Asterisk input/output parameters asterisk the primary way to pass data between tasks is through input and output parameters. Tasks receive input data in the task input data dictionary and return output data in the task_result.output_data dictionary. Asterisk workflow input asterisk workflows can receive input parameters when they are started. These parameters are available to all tasks in the workflow through the $workflow.input.parameter_name expression. Asterisk task output asterisk the output of a task can be accessed by subsequent tasks in the workflow using the $task reference name.output.parameter_name expression. Asterisk global variables. Workflow context Conductor allows you to set global variables that are accessible to all tasks in the workflow. You can set these variables programmatically using the Conductor API. Asterisk external payloads. Example S3, database for very large data payloads. It's often more efficient to store the data in an external storage service, like Amazon S3 or a database, and pass a reference, example a URL or an ID, between tasks. Example, passing data between tasks. Let's say you have two tasks, task_A and task_B. Task_A calculates a value and task_B uses that value as input. Task A, worker. Task B, worker. Workflow definition asterisk. In this example, the input parameters section of task_B uses the expression $task_A_ref.output.calculated_value to access the calculated_value output parameter from the task with the task reference name of task_A_ref. 9. Advanced worker techniques. Asterisk long polling asterisk Conductor supports long polling, which allows workers to wait for a longer period of time for tasks to become available. This can reduce the load on the Conductor server and improve worker efficiency. The long_poll_interval parameter in the configuration object can be used to configure the long polling interval. Asterisk domain-specific workers asterisk you can configure workers to handle tasks only within a specific domain. This can be useful for organizing your workers and ensuring that tasks are executed by the appropriate workers. Use the domain parameter in the task result object to specify the domain. Asterisk rate limiting asterisk you can use rate limiting to prevent workers from overwhelming downstream services. Implement rate limiting logic within your worker code to control the number of requests it makes to external services. Asterisk event handlers asterisk Conductor supports event handlers, which can be used to trigger actions based on workflow events, example workflow completion, task failure. You can use event handlers to send notifications, update databases, or perform other post-processing tasks. 10. Testing Conductor workers. Testing is essential to ensure the reliability of your Conductor workers. Here are some testing strategies. Asterisk unit tests asterisk write unit tests for the individual functions that implement your task logic. Use mocking to isolate the functions from external dependencies, example databases, APIs. Asterisk integration tests asterisk write integration tests to verify that your workers can interact correctly with the Conductor server. You can use a test Conductor environment or a mock Conductor server for these tests. Asterisk end-to-end tests asterisk write end-to-end tests to verify that your workflows execute correctly from start to finish. These tests should simulate real-world scenarios and validate that the entire workflow performs as expected. Example, unit test. 11. Best practices. Asterisk keep workers simple asterisk workers should focus on performing a single, well-defined task. Avoid complex logic in workers. Asterisk idempotency asterisk design workers to be idempotent, meaning that they can be executed multiple times without causing unintended side effects. This is important for handling retries. Error handling implement robust error handling to gracefully handle exceptions and report errors to Conductor. Logging log important events and data within your worker code to aid in debugging and troubleshooting. Monitoring monitor the performance of your workers to identify bottlenecks and optimize their performance. Configuration use configuration files or environment variables to manage worker settings. Version control use version control to track changes to your worker code and workflow definitions. Documentation document your workers and workflows to make them easier to understand and maintain. Security implement appropriate security measures to protect your workers and the data they process. This may involve authentication, authorization, and encryption. Use heartbeat for long-running tasks. Use task result status.in_progress to send heartbeat to Conductor. 12. Troubleshooting. Worker not picking up tasks verify that the task definition exists in Conductor and that the name matches the task_name in your worker code exactly. Check the worker logs for errors. Make sure the worker is registered with the Conductor server. Ensure that the workflow is configured to use the correct task definition. Check the Conductor UI to see if the task is stuck in the queued state. If you're using a domain, make sure the worker is configured to handle tasks in that domain. Task failing with errors examine the reason for incompletion field in the task result to identify the cause of the error. Check the worker logs for exceptions or other error messages. Use debugging tools to step through the worker code and identify the source of the problem. Make sure the input data to the task is valid and in the expected format. Communication issues verify that the Conductor server is running and accessible from the worker. Check the network connectivity between the worker and the Conductor server. Make sure the firewall is not blocking communication between the worker and the Conductor server. Concurrency issues if you're using multiple threads in your worker, make sure that your code is thread safe and that you're using appropriate synchronization mechanisms to prevent race conditions. Monitor the CPU and memory usage of your workers to identify performance bottlenecks. Conductor UI issues clear your browser cache and cookies. Try using a different web browser. Check the Conductor server logs for errors. Example error message, and possible solution. Reason_for incompletion, key error, number 1. This error indicates that the number 1 key is missing from the task input data dictionary. Possible solutions. Double check the workflow definition to ensure that the input parameters section of the task correctly maps the workflow input to the task input. Verify that the workflow is started with the correct input parameters. Make sure the task definition includes number 1 in the input keys list. By understanding these concepts, applying best practices, and having a good troubleshooting approach, you can build reliable and scalable workflows using Netflix Conductor and its powerful worker capabilities. Good luck.